All right, so previously we talked about collisions that just go either east-west or north-south, right? Things that are moving in the same, like, plane, kind of, right? Things that are moving on the same axes, just north and south or just east and west. But now we're going to start looking at a combination of those things. So an object traveling east and an object traveling south would collide, and then what do we think is going to happen after that, right? So now we're going to put some angles into it. So we'll have to deal a little bit with breaking down vectors. We'll deal with putting things into x and y, because what's the one thing we know about the x and the y direction? Can we ever put them in the same equation? No. So all that we're doing here is, it sounds like a lot, but we're basically doing the same problems, but we got to do one in the x direction and one in the y direction. So if it's an elastic collision, we use the elastic collision equation, but we just have to do it twice, right? One for all the x values and one for all the y values. So it's not any more difficult. It's just a little bit more tedious, I would say, or systematic, right? We've got to make sure we've got all of our x's in line and all of our y's are in line. So I'm going to show you the method I use to kind of stay organized and figure out what's x and what's y, and we'll go from there. So there's not much I need to teach new. It's just we're going to try some problems. So this one says a puck with a mass of 0.5 kilograms is moving 2.4 meters per second east. Okay, so I'm going to make that my object 1. Object 2 has a mass of 0.3 and it is at rest. Okay, it says after the collision, the first puck moves 1.8 meters per second at 30 degrees north of east. And then it says, what's the speed and angle of the second puck? Okay, so we've got two different objects here that we're looking at. So if they're ending up apart, what type of collision is that? Elastic, right? So we're going to use the equation for elastic collisions, but we're going to do it twice. Once in the x direction and once in the y direction. So when I lay out my variables, I just kind of put them in a line here. So mass of the first object is 0.5. And then I'm going to have v1x, v1y, right? That's initial velocity of the first objects in both the x and the y directions. And then what other two variables will I have for that object? v1x prime and v1y prime. Agreed? Right? You might not have every variable for those, right? If it's moving purely east like this one is, that means that my x value is 2.4, but what would my y value be? 0, right? 0. Because it's moving purely east. There's no y component of that. If it makes you feel better to draw out all of those vectors, you can, right? If I was going to draw out all the vectors, I could say that, v1 is moving 2.4 east. And so that tells me obviously that v1x is 2.4 and v1y is 0. I don't think you have to do that, especially for ones that are purely horizontal or purely vertical. But for ones at an angle, we will draw it out and break down that vector to find its x and y components, okay? All right, now for the second puck, it is at rest. It has a mass of 0.3. So v2x and v2y. Okay, you'll notice to keep myself consistent, I almost always list x's first. I almost do the work for x first, right? That's just the system that I use to kind of, make it a little easier for me. So I'll always do that first. Oh, I wrote a y. v2x prime and v2y prime. Okay. So it says my second object is at rest. So what does that mean? These two values are both going to be 0. Okay. And then my question mark is both v2x and v2y. I still have something to do here with this 1.8 at 30 degrees north of east. Okay, so I'm going to draw this vector up here. This is v1 prime. And I'm going to draw that vector. North of east means my angle goes here. And what would my sides be called here? If this is v1 prime, right? This hypotenuse is my 1.8. But what would I call this side right here? V1x. Not x. Oh, yep, v1y prime. And my x side would be v1x prime. Okay, so now I just solved those using trig functions, right? For x, I would use which one? For v1 x prime, I would take 1.8 times cosine of 30. This is important when our calculator needs to be in degrees. Okay, 1.8 times cosine of 30. And I get 1.6 or 1.56, wherever you want to round that, I don't really care. v1y prime would be 1.8 times sine of 30. Okay, 1.8 sine of 30. That gives me 0.9. All right, so now I can come plug those in right down here. 1.6 and 0.9. So now before you do any math, I'm going to recommend that you go back and make sure in your problem you didn't have anything that was moving west or south, right? Bless you. That none of your components need to be negative. Because if you forget the negative here, it's going to trickle down to a lot of different problems, right? Because after we solve all of our x's and y's, we build our new triangle at the end, kind of like vector addition. So if you forget a negative here, right, that's going to mean that our v2x prime could be wrong, and then our triangle is going to be wrong. So it's going to be an issue, right? So the negatives are really, really important. In this case, we didn't have anything that's going to be negative. But I want you to see here if we can predict what we think this is going to happen, right? My second object starts at rest. My first object moves east. Okay, after the collision, my first object goes here. So where do you think my second object might be going? Okay, forward, just straight forward? I think it might go in that direction, right? That's the prediction we can make, just based on what we know of collisions, right? If that's momentum is conserved and one of them's going north as well as east, the other one's probably going to be going south as well as east. It would be a shock to us if our second object ended up going that direction, right? So things to be aware about as you do the math. We're looking for our y component maybe to be negative, but probably not our x component. It shouldn't be negative, okay? All right, so let's go ahead and do the math here. When I do these math problems, I don't know why I do this, but I always label it as px. That's momentum in the x direction. I kind of give myself a little workspace to just do the x problem. Okay, so px just means momentum in the x direction. And then I plug in my numbers here. So mass times v1x, 2.4, plus mass times v2x, which is 0, equals mass times v1x prime, 1.6, plus mass times v2x prime, which we don't know. All right, and then let's solve the math that goes with that. This would be 1.2. This gets dropped because it's times 0. 1.6. 0.8 plus 0.3 times v2x prime. So I'm going to combine my like terms with the 0.8 and the 1.2. I'm going to subtract this one over. That gives me 0.4 equals 0.3 v2x prime. And then I'll divide. And v2x prime, I get to be 1.33. And it came out positive. Is that what we were expecting? My x variable we expected to be positive, right? It's still going to continue to move east. Okay, so I'm going to come up here and change that in my list. 1.33. Okay, now for the y component. I'm going to do it up here at the top. Okay, again, I label it py. I don't know why I draw the little brackets. It's just a habit I have. They don't mean anything. They have no mathematical significance. It just helps me stay organized. M1 times V1Y, which is 0, plus M2 times V2Y, right? Do you need to bother plugging in the whole left side if it's all going to be 0? Right, you're welcome to leave it off. I'm just writing it out so that we can see it. Okay, 0.5 times 0.9, and then 0.3 times V2Y prime. So we're going to have 0 on the left, 0.45 plus 0.3 v2y prime. I'll subtract that 0.45 over, so that gives me negative 0.45 equals 0.3 v2y prime. And that gives me a v2y prime of negative 1.5. Okay, and does that kind of match the expectation we had for that object? Moving east and south, yeah, okay. So, our goal was not just to find the components of that, negative 1.5, but it was to find the speed and the angle. So now we build a new triangle with those two new components, okay? So I'm going to come over here, and I'm going to draw my triangle. I know I'm going to go east and south, so I'm just starting my origin right up here. It doesn't matter if I go east or south first, but I'll just go east, 1.33, and then south, 1.5. Let me do that a different color. So the answer, or my actual final velocity, is this blue line. All right, so we'll need the actual hypotenuse and the angle that goes with that. Okay, so we're doing Pythagorean theorem to find that hypotenuse, and then we will use, I like to use tangent there to find the angle. For my hypotenuse, I got about 2 meters per second. Okay, and for my angle, I'll use second tangent. Remember, when we're solving for the angle, we'll take the second function of that. Okay, so let me write my answer a little bit bigger here. All right, so I ended up with 2 meters per second at 48 degrees what of what? East of south or south of east? South of east. South of east, good. All right, so that means post-collision, my second object is going to move 2 meters per second. Post-collision, my object's going to come off with that speed at an angle of 48 degrees south of east, which is what we expected. All right, for the most part, you're going to be able to take a guess at where that second object's going to go, right? It's rare that it'll be a complete surprise to you about what direction that second part is going to be going. But what questions do we have there? Okay, this says a 7 kilogram object moving at 12 meters per second explodes into 2 unequal parts. The 5 kilogram fragment moves 15 meters per second south after the explosion. What's the velocity and direction of the second fragment? So, a couple different ways we could go about this. You could set this up as a reverse inelastic collision if you wanted to, because they're starting together and ending up apart. Or you can just treat them as a 5 kilogram object, and then what's the mass of the second object have to be? 2. You can just treat them as those two objects happen to be doing the same thing pre-collision, right? And then they end up. So you can do it 2 different ways. Is there a way in particular that you want me to show it? You want to keep them as 2 objects or as 1 object? Keep them as 2. That's fine. Okay, so that means our first object is going to be our 5 kilogram. So I'm going to call M1 equal to 5 and M2 equal to 2, right? Because the total mass of those combined is 7. So that's how we know our second object has a mass of 2. Okay? They are both, before the collision or the explosion, right? Both moving 12 meters per second east, which means that V1x is equal to 12 and V2x is equal to 12. What's the second part of knowledge that we have from that statement? That's right. V1y is 0. And what's V2y? 0. Also 0. Okay, very good. Does that part make sense how we set them up? Mathematically, it's going to be the same to do 7 times 12 or 5 times 12 plus 2 times 12, right? Mathematically, it's going to be the same. So however you want to set that up is fine. All right, post-collision, our 5 kilogram object is moving south. So that means V1x prime would be equal to what? 0. And V1y prime would be equal to? Yeah, good. Negative 15, right? South tells me it's got to be negative. That's really, really important. Okay, the south has to be negative. And then we're solving for V2x prime and V2y prime. Okay. I'm not going to tell you that we're always going to solve for the second object. I don't know. That's just typically how it goes. But sometimes you have to solve for the initial velocities of something too, but it's not as common. All right, so let's go ahead and set up. I just like to do the x first for no real particular reason, but that's what I do. Okay, so I'm going to go 5 times 12 plus 2 times 12 equals 5 times 0 plus 2 times v2x prime. This will give me 84, which you'll notice is the same as 7 times 12. And so I get v2x prime equal to, I got 42. Is that what you had?
Yeah.
And positive, which means it's going to be going in what direction? East. Okay. Yeah. And sometimes I even like to put a little arrow to remind myself what direction it's going to end up going. Okay. Not necessary, but a good reminder. All right. So my whole left side of my y equation is going to be what? 0, because all my objects are moving east to begin. So I could just put 0 equals 5 times negative 15 plus 2 times v2y prime. Okay, 15 times 5. I should be able to do that, but I didn't. Okay, that gives me negative 75 plus 2 v2y prime equals 0. So I'm going to move 75 to the other side. And that gives me a v2y prime of positive 37.5, which means that's going to be going north. So does that part make sense, right? If I've got an object that explodes and one of them goes purely south, that means the smaller object has to go north, right? They've got to split because the momentum's got to be conserved. So they can't both go the same direction, right? That would not show a conservation of momentum. You've got to have them go in opposite directions there. So now I just build my triangle and then I'm done. Any questions about how we solved for either of those? v2x prime or v2y prime?
Which one do we draw first? Do we draw the x or the y?
It makes no difference. If you draw it differently than mine, our angles will be complementary. But mine might be north of east and yours might be east of north. Right? So it doesn't make a difference which one we do first. I usually just draw the x first. But again, that doesn't really matter. Okay, so here's 42. And then here is 37.5. And so what I'm really looking for is this hypotenuse, right? It's back to like just basic vector addition here to find that hypotenuse and the angle. Okay, so that gives me 56.3 meters per second at, and then to find the angle here, I'll go second tangent of opposite over adjacent. Again, you've got all three sides by this point, so you could use second of another function, but I don't want to. 41 point, let's call it 8 degrees, and then what of what? Yep, very good.